So this is 3-8, 3.8, number 31. It's asking for the second derivative. And here's what you have to remember. Y. That there tells you that y is your function. It's like a f of x or a g of x. It's not your variable. X is your variable. So that's your variable, and that is your function. So when we take the derivative of x, it's easy. That's just 1. When we take the derivative of y squared, you have to view this as like a f of x or a g of x. It is a function. So the rule is the power rule. You bring the 2 in front and you decrease the exponent by 1. So the derivative of box squared will be 2 box to the first times the derivative of the box. But what's the derivative of y? dy dx. That is the derivative of y. And the derivative of 1 is 0. So now I'm going to isolate dy dx. This one is pretty straightforward. I subtract 1 from both sides. I divide both sides by 2y. Now, I'm going to give you some important secrets that's going to save you time and make your life easier. At this point, we're supposed to take the derivative of both sides. The left side's easy. We already have the derivative. The derivative of the derivative is the second derivative. Now, the right side, some of you did quotient rule. Quotient rule works. It's legitimate because you have a function, y equals 1, over a, whoa, that was weird, over a function, 2y. But remember this, if you ever have a constant, you don't have to do a quotient rule or a product rule, you rewrite it. So you don't see it, but there is an exponent on the y. There is a 1 there that you don't see. So you can rewrite this like this. Negative 1/2, you bring the y to the top and the exponent becomes negative. So you have to see that manipulation. That's just the basic properties of exponents. So now this problem becomes negative 1/2 box to the negative 1. So when we take the derivative, the constant gets copied and we take the derivative of box to negative 1. Well, that's a power rule. You bring the negative 1 in front and you subtract 1 from the exponent. So we bring the negative 1 in front and we subtract 1 from the exponent, it becomes negative 2. But remember, this is box. It's a function, so you have to multiply by the derivative of box at the end, but the derivative of y is dy dx. Chain rule. Let me erase all these boxes so it's a little prettier. And we're pretty much done, except we have a problem. So I like these two negatives because they cancel. And I have a top and I have a bottom. On the bottom, I have a 2, and that negative moves this to the bottom. So I have 2y squared on the bottom, and then I have a dy dx. dy dx is our issue. We want our answer with just x's and y's. So what do we do? What do we do? Look, we know dy dx. It's negative 1 over 2y. So what we're going to do is replace dy dx with its equivalent. So let me copy and paste that. So we need to take this thing and replace it with that, because that's the equivalent. So let me copy that. I'll paste it here. And I'm replacing the dy dx, so let me delete that. And there we have it. I lost my fraction bar. You can combine these. Negative 1 over 4y cubed. Dun, dun, dun. There is the second derivative.